Hello, and welcome to today's OAUG Vendor Awareness Session on Oracle Database Security and Data Management in Action. My name is Julie Lochner, Vice President of Sales Operations at Solix Technologies. Today we will be discussing securing non-production environments, deploying database auditing, and automating data management for your Oracle applications. We will begin today's discussion describing challenges with existing data management practices, how Solix addresses these challenges with Solix's Enterprise Data Management Suite, one tool for auditing, data masking, subsetting, and archiving. Most data centers have a production environment and a clone for standby or disaster recovery, and will also make multiple clones for reporting, test, development, and training. These clones are restored from backup or are shipped off-site using some technology, maybe a split from a business continuous volume or SAN copy or even just FTP. But in most cases, the security and audit policies are in place for the production environment only. If sensitive data, such as personal information or company confidential, resides in the production database, that sensitive information will also reside in every clone. DBAs may or may not run scripts on the clones to mask or secure the sensitive information. The cloning process to create those clones is typically manual, time-consuming, and not audited or monitored. And in most cases, the clones are full clones, which consume a lot of disk. Analysts estimate that on average, 54% of database data is considered confidential. Forrester estimates that more than 80% of security breaches are from insiders. Types of sensitive data that need to be protected include sensitive data such as retail customer information, patient data, personnel data. In manufacturing, if you're in the food industry, batches, secret recipes, pharmaceutical clinical trials, or even financial and customer and sales data from a company confidential perspective. Solix's approach for enterprise data management combines best practices including security, auditing, and archiving. First of all, you want to keep an electronic paper trail of all processes, including the cloning and any data that needs to be monitored within those production environments. Secondly, eliminate risk through automation and data masking. Streamline and automate the cloning process in a repeatable process that includes data masking. This way, as soon as the data is cloned, sensitive information is protected. Once the baseline is secure, it can then be used as a source to create multiple clones. If you combine cloning with the subsetting process, you can either reduce the storage requirements for your clones or create more copies in the same store. Finally, archiving removes redundant data from production of all clones. By selecting archive-eligible transactions from the production environment and storing it in a central secure archive that's available to the production application, all of the clones are significantly reduced. And when you move all of your archive and your clones for test and development to a Tier 2 environment, you can leverage a tiered storage and infrastructure to lower your total cost of ownership. Solix's approach is simplified with a unified platform. The Enterprise Data Management Suite is comprised of solutions for compliance and information lifecycle management. On the compliance side, we provide complete solution for secure test and development processes, including data auditing. And on the information lifecycle management solutions include enterprise data archiving and application sunsetting. Each solution is supported by Solix's Enterprise Metadata Manager. The centralized metadata repository allows a single installation to manage many applications, many solutions, and many data types, all from one server. It is a modular architecture such that you can enable the functions as needed and then add additional solutions to leverage the existing investments. Solix provides support for packaged applications as well as a drag-and-drop configurator for other solutions and customizations that you may have in your data center. The Solix Enterprise Data Management Platform leverages a centralized metadata repository that uses a knowledge-based approach for the applications that are to be managed in the data center. The knowledge base includes the information about the tables and the relationships between them of the tables that need to be managed, whether it's archiving, subsetting, masking, or auditing. Solix takes care of managing the different data types, whether it's an Oracle, DB2, SQL Server, email, or documents and files. The server enables the functions through a license model such that you can enable the compliance or ILM solutions as needed. The Solix Enterprise Data Management Suite leverages a three-tier architecture. The console for administering and defining policies is a browser-based user interface that supports the most popular browsers. The application tier is a J2EE application that supports applications and has been certified on technologies such as Oracle, IBM, SAP, as well as open source Tomcat. The repository for the metadata can either be an embedded repository or leverage an existing database that you may have, such as Oracle, DB2, or SQL Server. All of the policies are defined in the console, and the policies are enforced at the data tier. If you've deployed tiered storage or tiered infrastructure in your data center, this can be leveraged through Solix. Let's move to the demonstration. We begin by logging on to Solix's Data Management Console using a username and password for authentication. Once we logged in, we can select the knowledge base or the application in the data center that we want to manage. So for example, you'll notice we have Oracle ERP 11i and 10.7. You can have multiple knowledge bases and one that matches every application in the data center. Now once you select the knowledge base, you'll notice that there's configurations that are already pre-populated for this example for General Ledger. Now you'll notice not all of the tables for General Ledger are listed here, just those tables that are specific to the JLJE badges, the headers, lines, and import references. This is the metadata of the tables that we will use to manage whether it's archiving, auditing, or subsetting going forward. Another example is with accounts payable invoices. You'll see this metadata knowledge base is a little more complicated because there are quite a few more tables that are representative from an AP invoices. Once we've mapped the metadata and have captured information about the business application that we want to manage, we are able to collect instance statistics. This example shows the distribution of the data by business application module. So for example, you'll see that General Ledger takes up about 14% of this particular database. This is helpful when determining how much data is eligible for archiving or where your biggest pain points may be associated with data volumes and growth. More information is available by taking repeated snapshots over a periodic basis to determine where the data is growing. And then you can also see that we have some built-in analytics to determine how much data could be eligible for archiving. This snapshot statistics can be set up on a recurring basis to give you an idea of where the benefits may be from an archiving perspective. Next, we look at auditing. You'll notice that we have several audits already defined in this particular example. For example, we wanted to audit in an Oracle 11i environment the PO headers all and make sure that the amount limit is we audit anytime someone makes an update to that particular limit. This is as simple as selecting the audit, defining the type of audit that you want, whether it's trigger or database or some other function that's native to the database technology. Once the audit has been deployed, you'll get a notification saying that this particular audit flag has been enabled, and we'll start recording any event based on that policy to a central audit repository. Solix also deploys system-level auditing. This is important for auditing events such as any time an archiving takes place, if you're going to be creating clones or doing any subsetting or masking, or simply if you want to have a trace on any user that is using the Solix Enterprise Data Management Suite. When we talk about data security, Solix's policy-based approach allows you to define a security policy based off of the metadata in the knowledge base. By using a knowledge-based approach, when the data is masked or secured, the data referential integrity is maintained. Solix ships with more than 15 provided functions, and the masking process can be automated with an integrated cloning technique. This allows the data to be masked, streamlined, enforcing segregation of duties and mitigating risk associated with unauthorized access of sensitive information. Defining a masking policy is as simple as doing a drag and drop point and click process. The knowledge base is selected, the security rule that's defined, such as in this example, credit card null, so we will be nulling out credit card information in a particular table. And then when we deploy that policy, we map it to the specific business application and the tables that contain the credit card information. The second part of creating the secure test and development solution includes using an instance subsetting approach. What's nice about including subsetting with your cloning process is it allows you to reduce the size of your test and development copies based off of a policy. It's integrated with the cloning process, especially with Oracle E-Business Suite 80 and pre-clone and 80 post-clone processes, so that when the subset is complete, that the application is completely functional and supported by Oracle test and development processes. So here's an example of creating a subset policy by invoice date. Again, because all of the knowledge base is stored in the centralized repository, we can use that metadata knowledge base over and over again. So in this example, we're using invoice date against the AP invoices all table. We're using a parameter. If you'll notice in the value, there's a $sign before the invoice date. When we actually run this invoice policy, you can define the invoice date for that particular subset run. When we execute the subset run, we have different options for the method to actually create the subset. Solix offers many approaches depending on the volume and the size of the database that is to be created in the subset environment. Truncate and delete options are available such that if you start with a full volume clone and you want to just delete or truncate a small set of data or truncate a large volume of data, this approach is useful. For creating a subset where you want to just have a right-sized clone, you can use the insert method where you start with an empty database and you insert just the data that you want as part of that subset environment. So for example, when we were talking about the different subset methods, for the delete and truncate, what we're talking about here is an in-place subsetting approach. So the benefit of using the delete or the truncate method is it's really good when you have, for deleting, it's when you have a very small amount of data that needs to be removed. Truncate usually works when you have some tables that you can just truncate or delete. Both of these approaches are good from the perspective if you have a lot of extra disk that you can leverage for creating the cloning process. The disadvantage of this process is that you do need to start with a full volume clone and then you kind of self-destruct that clone to create further clones. With the insert method, which is Solix's unique approach, we use an insert method, and this is a Solix exclusive. This requires the least amount of storage, and you can create those clones right-sized based on the target amount of data that you need. So you insert the most up-to-date data, whether it's a refresh from production or directly from production, and it really is the quickest subset method because you're only inserting data that is needed for that particular test environment. This method is really good when the amount of data that you want in the subset is approximately less than 30% of the data from the total amount that might have been in production or the recent clone. No matter what method you use, whether it's the in-place subset or the insert method, the cloning and the masking process is completely automated, eliminating risk of someone having unauthorized access to that sensitive data. Within the cloning process, Solix is integrated with several replication options. The simplest approach that has no prerequisites is using a file copy approach. The second approach that we've integrated with is cloning. So for example, if you're using any type of disk-based replication, we can call out to that cloning process. So this would require the same source and target storage and infrastructure technology. Another approach that we integrated with the copy is what we call pointer-based copies or snap copies. These are nice because they leverage a fraction of the storage space, but they also require the same source target. Most of the storage vendors have snap and clone capability as optional licenses on top of the storage frame that you can purchase. Another approach that we are also integrated with is a heterogeneous block-based replication technology, such as NetApp recently acquired a company called Topio. What this allows you to do is replicate block-based using across network protocol from source to target. The benefit here is that the source and target do not have to be the same type of storage technology. So if you're an EMC or HDS shop and you want to create your test and development clones on a different platform, this technology is useful in that scenario. One of our recent customers was required to secure test data and lower their costs at an outsourced data center. By combining the data masking and the instance subsetting solutions from Solix, they were able to eliminate risk of exposure by masking sensitive data such as HR, payroll, and personnel data before releasing the clones to their test and development resources. They were also able to significantly reduce chargeback costs because by using an automated cloning method, they were able to reduce the process from 11 days to less than 11 hours, which is a significant reduction in people and manual hours charged to that process. In addition, they were able to reduce their storage requirements by more than 50% for the test and development copies. Now, because they've mapped the metadata for these particular applications in this environment, they extended their data management strategy through a phased implementation and added archiving as part of a phase 2. Now, just to give you an example of what that looks like in Solix's Enterprise Data Management Suite, here we're showing the definition of creating an archive criteria for General Ledger. And again, it looks very similar to the subsetting, but here the process, we have a process that requires a validation criteria where we're looking for the period that is targeted to be archived and to make sure that the booking period is closed and that all of the transactions that are related to that particular booking period are eligible for archiving. Once we run the archive method, when we actually execute the policy, you have a couple of options as well. You can do an archive and purge as a one function. We'll archive the data to an archive repository and then purge the data from the source. You could do a purge only, an archive only, as well as leverage a partition if the database technology, underlying database technology has advanced partitioning methods enabled or the licensing enabled, you can leverage a partition method to move the data to the target archive. Additional utilities that Solix ships with its data management suite include things like patch synchronization and scheduling. This patch synchronization is useful if you have a production database and you're archiving to a target database. When you apply a patch to the production environment, sometimes you may need to apply a patch to the archive if, for example, the tables or the columns have changed because of the patch. We provide an automated process to synchronize both the production and the archive databases through the patch synchronization utility. In addition, for subsetting and also with archiving, we have an integrated space reclaimer technology. We also include in our base license the ability to do what we call Grand Archive. Grand Archive allows you to take sets of data and archive it to an encapsulated XML file so that if you need to archive data for a very long period of time, because it's in an encapsulated XML file, it is independent of the database technology stack, the operating system, and the version of the application. So it becomes a snapshot archive. And also integrated in the suite is darchive. You never know when you need to bring that information back, and we have a very elegant way of bringing the information back either by archive batch or by a specific transaction. Another example of a customer case study is one of our customers, Helen of Troy. If you're familiar with the Revlon or Dr. Scholl's or Vidal Sassoon products, then you'll be familiar with the products of Helen of Troy. This particular company had an issue with application performance, and the size of their database is growing, as well as their backup windows and their restore windows. So by deploying a database archiving solution, they were able to significantly improve their application performance by reducing some of their supply chain report runtimes by 20%. They improved their online and background processes by as much as 30%. They were able to have predictable storage management processes as well as achieve a cost savings associated with deferred storage and CPU capital expenditures. Again, because they leveraged a centralized metadata repository, they were able to add email archiving in phase 2, leveraging that existing database application solution. So Solix does solve customer challenges by securing data in the test and development copies by having an integrated data security policy. You've seen through some of the examples and some of the demonstration how we're able to reduce the cloning time through an automated process. When we, in one case, we've reduced the amount of time it takes to clone from 11 hours to less than 11 days to less than 11 hours. By including a instant subsetting process with your cloning, you can also achieve reduced storage and server requirements in your test and development process because those copies are right-sized for that particular purpose. And then by keeping track of who changed what, when, and how, you have a complete audit trail that records critical steps and events in your data management processes. We'd like to thank you for joining us today for our presentation on Solix's data management capabilities, and hope that you see the benefit of using something like Solix's Enterprise Data Management Suite to lower risk while staying compliant and reduce your total cost of ownership. For more information, please visit our website at www.solix.com or call one of our specialists at 888-GO-SOLIX, or simply email us at info@solix.com. Thank you for joining us today, and we hope that we have provided information to help you achieve better data management practice. Thanks.